Welcome to my projectbazaar.com.
Now we discuss about the product for compiler assisted leakage and temperature aware instruction level VLIW scheduling. Next we see the abstract for the product. Stream processor are widely employed for media applications by exploiting various level of parallelism to improve performance. Cluster are the main computing part and two most power consuming and hot components in stream process. Such imagine Strom and AMD and functional unit, which are controlled by very long instruction word. Is most stream processor in VLIW architecture operation can be executed simultaneously on multiple functional units to exploit instruction level parallelism. Unfortunately, the large number of functional units and increased operations per VLIW bring serve energy increase and thermal problems for stream processors. A wide variety of technique targeting leakage energy reduction has been proposed for different design levels. Among with compiler assisted power gating technique has been demonstrated efficient and promising for VLIW architecture by partial power shutdown. Despite of the computation intensity of media applications, still a big fraction of functional unit are ideal or not frequently used due to the inherent intervals of functional units can be combined intensively in both temporal and spatial dimensions. So the more ideal functional units are powered down and less switch overhead are included. However, the less attention is paid on temperature management in these schemes allow the low power design can reduce the chip temperature by reducing the average power density. Localized peak temperature does not decrease necessarily. Some low power mechanisms affect conflict with temperature management because the temperature influence not only by power but also the area and power distribution of compiler assisted leakage power management. Then with the technology scaled into nanometer scale leakage energy consumption in accommodating for the greater power proportion than ever, especially when the very long instruction word architecture with large number of functional units. The growing energy consumption leads to an increase in chip temperature, which gain bridge an exponential growth on leakage current and consequently leakaging energy level. However, few studies of VLI architecture in this paper, the leakage and temperature aware designs flow is presented to assist the leakage compiling of instruction level of VLIW scheduling, and two scheduling algorithm are proposed for the design flow. First, the leakage power rescheduling algorithm is proposed to energy containing operation for favor functional unit and concern, and to modify the aware instruction level of VLIW scheduling and to apply the hybrid based equations for VLIW scheduling process modification in our aware instruction architecture. Next we see the flow diagram for the product. First we apply the instruction from CPU unit and to find the address in DRAM functions. This is the first memory based process, and to apply the hybrid combined memory scheduling technique for extract the page of VRAM architecture. This DRAM and VRAM two kind of memories combined with VLIW processing. This for memory scheduling technique for our overall architecture, and the memory scheduling technique algorithm to be combined for memory scheduling architecture level. This algorithm to be combined and to reduce the processing scheduling time for overall memory functions. Then the address allocation process to effectively improve for combined with DRAM and VRAM page allocation work. Then reallocate the page from DRAM architecture based on our exact page from VRAM functions, and to update the page in VRAM function for final architecture level. This is the overall flow for instruction from CPU functions, then the PRAM and DRAM memory allocation scheduling for overall function architecture. This is our the main work for combined memory scheduling. This is our modification work to combine the algorithmic representation of page allocation in two kind of memories in our overall VLIW architecture results. This is our the processing performance for our architecture results in our flow diagram process. And finally we see the output for the product. First we run the overall memory scheduling tuning memory management unit for using the Xilinx IC project. Our program was developed in VHDL language. This architecture mainly manage the overall memory scheduling unit for overall architecture process. Thus the scheduling based process to apply the address function and to instruct the schedule for data processing for memory scheduling technique. Then to select the memory management unit and to select the simulation process, then to run the simulate behavioral model. This behavioral model mainly used to simulate the our overall processing architecture results. Then to run the simulation result and to apply the binary based input and to apply the processing performance level. Then to select the clocking signal for activate the our memory scheduling process. Then the read signal to read the addressing allocations and data function. Then reset function to be deactivated. The enable function to be activation. Then to apply the address input for our required memory scheduling. Then to apply the binary input results and to apply the data function for any type of combinational data to the required read and writing process. Then activate the enabling functions. Then to activate the read functions for our overall processing results. Then to run the clocking signal and to apply the clocking pulses continuously for overall architecture results. Then the clocking signal to continuously processed by final output result functions. Then to calculate the scheduling results for overall functioning process. This is our final simulation results for allocating the memory allocation for two type of processing results to allocate the memory and to passing the data function for any type of processing results and to change the state position for address and row for allocation and read the data for PRAM and DRAM memory architecture for overall simulation results. Then to select the implementation process and to run the RTL diagrammatic representation for overall architecture. This is our diagrammatic representation. This representation mainly used to what are the logical blocks present in our overall architecture. Then go to the technology diagram. This technology diagram mainly used to what are the input and output functions and lookup tables and wire connectivity for overall VLIW scheduling process. Then go to the design summary process. Then calculate the synthesis report for overall result functions. This is our device utilization result for overall area of VLIW scheduling results. This is our memory scheduling processing time and frequency level, then the latency level of overall processing level for overall architecture. This is our simulation and synthesis results for memory management unit and compiler leakage scheduling technique for overall architecture results.